Hello students and friends, welcome to my YouTube channel. Today I am going to discuss the half range cosine series problems. So this is the given questions fx equal to x in terms of interval is 0, pi. So this is the Fourier series expansion. So here suppose we know the cosine series, that means bn will be cosine series, that means bn will be 0. So we know that right here. We know that for cosine series bn will be 0. Cosine series bn will be 0. So what is our Fourier series? fx equal to a0 by 2 plus summation n is equal to 1 to infinity an cos nx. So what is our unknown? a0 and an we have to find out. If we substitute this equations number 1, we'll get the solution. So we'll start now. What is the an? So a0 first. a0 is equal to a0 formula will write 2 by pi. We'll write 2 by pi integral 0 to pi fx dx. So what is fx dx here? 2 by pi as it is 0 to pi x dx. So you integrate this 2 by pi, then you will integrate x square by 2 will come. So apply the limit, upper limit minus lower limit. So what is the upper limit here? Pi. So it will come pi square by 2 minus 0. So already I told, if the limit will be a to b fx, what is the process to the substitute the limit? So fb minus fa. This is the fb minus fa, upper limit minus lower limit, upper limit minus lower limit. Okay, so this way we did. Now what is the solutions here? a0. So it is coming 2 by pi into pi square by 2. So it is coming only 2 get cancelled, pi get cancelled, so it's coming pi. So a0 we are getting pi. Okay, and finally if you want to write here a0 by 2 is equal to pi by 2. This is the value. Now become the an. Similar we will write here 2 by pi 0 to pi fx. What is there? Fx cos nx. Cos nx. If you find the an no cos nx. Okay. So this now will substitute the value here. 2 by pi 0 to pi fx is x cos nx. This here dx, because integration is there, not dx must will be there. So x dx. Now you look here, two terms with there, u and v. So you know the u and v integrations. Before also I wrote u v1 minus u dash v2 plus u double dash v3 plus dot minus dot. Okay. So now first functions u will write here. What is the u here? Now integrating na right here 2 by pi as it is u na x v1. Okay, that you have to write first here. So u is equal to x, u dash equal to 1, u double dash equal to 0. Then v is equal to cos nx. Then v1 is equal to sine nx. Sine nx. Then integration meaning the differentiation of this in denominator. So n. v2 is equal to minus na cos nx. Again one more n will come, n square. So u dash one u double dash not existing. So v3 not required. Okay. Now substitute u na x v1 sine nx by n. Formula minus. Any minus is there? u v1 u dash v2. So v2 will be minus, u dash is 1, so minus plus cos nx by n square. Limit 0 to pi. Now we'll substitute here. So sine n pi, already you know here, also you know sine n pi. Sine n pi equal to 0, cos n pi equal to minus 1 power n. This also we know. So one sine terms will be there na, directly this will get 0. So what is the remaining terms is the 2 by pi cos nx by n square. Now apply limit 0 to pi. Now we'll apply the limit 0 to pi. So what will be there here? 2 by pi upper limit cos n pi. How you write from here? I am writing from here. That implies 2 by pi upper limit. What will come? Cos n pi by n square minus cos 0 1 by n square. So this is the expressions we got. Now we take the common or substitute the value. Common not required. So cos n pi. So n square you take common. Pi. We can take pi n square. So cos n pi minus 1 power n minus 1. If like this terms will come, any one terms will exist, either even functions or odd functions. Now suppose n is equal to n is even. N is even means 2, 4, 6. So if we'll square, it will get 0. So even functions, that means what is Fourier coefficient? A n will be 0. If n is odd, that means 1, 3. So this will come minus. So minus 2 will come. So I am writing here what is 2 by n pi square odd function. So it will come minus 2. It will come minus 2. So you can write minus 4 n pi square. Minus 4 n pi square. What is coming this one? This is coming for an. This is coming for an. Okay, now we will substitute this equation in our Fourier equation 1. So this problem I am going to rub it now here. This equations 1 should be there. Equation 1 should be there. Substitute Fourier coefficient. Substitute a0 and an in equation 1. So what is equation 1? Fx equal to a0 by 2. Directly I wrote here pi by 2. Then plus pi by 2 a0 plus summation n is equal to 1 to infinity. What is an? Minus 4 n square pi. Minus 4 n square pi. Minus 4 n square pi. How we wrote this? Minus 4 2 by pi. N square take common, so pi n square correct. 2 by n square pi minus 2, 4 by n square pi. So n square pi. Then what is cos nx? Cos nx. This is the Fourier series expansion. Now they are asking deduce that. Deduce that now. They are asking what is 1 by 1 square, 1 by 2 square now. So put x equal to 0. Put x equal to 0 both sides. So x equal to 0 now, here x will be there. So x, fx is x, so 0. Pi by 2 plus or take minus 4 by pi. Summations you take here. N is equal to 1 to infinity. 1 by n square cos nx. Cos nx na 0. So it will come 1. Cos x equal to 0 and it will come 1. Now we'll deduce this. We'll get the answer. So what is there here? Pi by 2 equal to 0. So now write here minus pi by 2 is equal to minus 4 by pi. Why? Because this we are taking this side. So minus pi by 2 summation n is equal to 1 to infinity 1 by n square. Now bring this side, because into it there, so cross multiplication. So this will come minus plus pi square by 8 is equal to 1 by 1 square plus 1 by 2 square, 1 by 3 square. This is the deduce the terms they are asking. So we will get these answers. Okay. So this is the final solutions for this given cosine series. Okay. Thank you students. Subscribe the channel and watch the video from beginning to end. Okay. Thank you.